everybody, this video is about how to take the common factor out of a polynomial. Well, your first step in taking out the common factor is to find the common factor. Now, it's not stated explicitly in the problem, but when it says common factor, what it really means is the greatest common factor. So, if you don't know how to find the greatest common factor of monomials, go see my video on doing that. But what we want to do is find the greatest common factor of these three monomials. We have 32, 20, and 8 for the coefficients, the numerical part, and then we'll deal with the variable part separately. This is the same as the hint that I gave in my videos on multiplying polynomials. So if I want to find the GCF, then I'm going to look at the numbers 32, 20, and 8. And if I need to use that table procedure from the prior video, you can. But 32, 20, and 8 are relatively small numbers, and thinking through the factors, we can see that the greatest common factor of those three numbers is 4. 4 goes into 32, 4 goes into 20, 4 goes into 8, but nothing bigger will. And then for the variable portion, we have 4k's, 5k's, and 6k's. So the most k's that they have in common is 4. So we're limited by the 4k's that we have in this first term. That's the most that they have in common. And now we're ready to take out this common factor. So what we're going to do is we're going to write that down, 4k to the fourth. And the idea is this is a factor, and when we multiply that by some other factor, we need to get back to this polynomial. So our other factor is going to be a polynomial with 3 terms, because we have to end up with 3 terms. So you can think about factoring like doing multiplication in reverse. And multiplication in reverse is basically division. There's a subtle distinction between division and factoring that's not worth going into in this video. But anyway, 32 divided by 4 is 8. We had 4k's, but we took 4 out, so we don't have any left. And now we move on to the next term. 20 divided by 4 is 5. We had 5k's, we took 4 out, so there's 1 left. 8 divided by 4 is 2. We had 6k's, we took 4 out, meaning there are 2 left. So we have successfully factored this original polynomial with 3 terms, and we factored it. I want to be careful about the way we're going to use these words here. 4k to the fourth, that is a factor. And then 8 plus 5k plus 2k squared, that is also a factor. And if you multiply this factor by this factor, just imagine, or let's actually look at it, if you use the distributive property, 4k to the fourth times 8, that's 32k to the fourth. 4k to the fourth times 5k, that's 20k to the fifth. 4k to the fourth times 2k squared, that's 8k to the sixth. So if you multiply this factor times this factor, you end up with the original polynomial. So what we did is we took this original polynomial and we broke it into 2 factors. And that's exactly what factoring is. And this is the most basic technique of factoring, taking out a common factor if there is one. So let's see what this looks like if we have 2 variables. So we have 2 variables this time, but the first step is the same. You want to identify the common factor. And again, deal with the numbers and the variables separately. So we have 66, 12, and 36. So we want the GCF. Well, you might think it's 12 at first, 12 goes into 36, but 12 doesn't go into 66. So 12 is not the GCF, we need to be smaller. How about 6? Yeah, 6 seems to work. So 6 is the numerical part, the coefficient of our GCF. Now let's look at the m's. We have 1m, 5m's, 6m's. So the most they have in common is this 1m. And now for the n's, we have 2, 2, and 4. So the most that they have in common is 2. So we're going to take out this GCF, by division. You can think about it that way. Like I said, factoring and division, they're not quite the same thing, but close enough. Now, there's a common, not really trick, but there's a common aesthetic when you are doing factoring. Notice all three terms here are negative. So when I divide by this common factor, I'm still going to have three negative terms. And in some people's minds, that's not very pretty. So instead of factoring out a positive GCF, let's factor out the negative and see what that looks like. It doesn't really make a difference if you don't factor out a -6. If you do a +6, it's fine. It won't be counted wrong. But let's just see what it looks like when we get to our final answer. So, -66 divided by -6 is +11. We had one m, but we took it out, so there are no m's anymore. We had two n's. We took two n's out, so there aren't any of those anymore. And then we move to the next term. -12 divided by -6 is +2. We had 5 m's. We took one out. That leaves 4 left. We had 2 n's. We took 2 out, so there are none left. Go to the next term. -36 divided by -6 is +6. We had 6 m's. We took 1 out. That leaves 5 left. We had 4 n's. We took 2 out. That leaves 2 left. So this is our answer. And you might see why some people prefer to take out a negative common factor sometimes. If we had divided by +6 mn squared, we'd have -11, -2, -6. We'd have a whole bunch of minus signs. And in some people's minds, it's a little prettier to have just one minus sign on the outside rather than 3 on the inside. And I think I agree. If I were doing this problem, I'd go ahead and factor out a -6 mn squared as well. But anyway, that's how you take the common factor out of a polynomial. And this is your first step along the arduous journey of learning to factor. Hope it helped.